Alright, so in this example problem, we want to know what the magnitude and direction of the velocity is at t equal 0.75 seconds if its position changes as the function below. So we have r of t equals 3 meters per second squared times t squared in the x direction, and 2.5 meters per second cubed times t cubed in the y direction. Alright, since we're going from position to velocity, that tells us we need to take a derivative, and the first derivative in terms of time. So that's what I've done here, and notice, so the first thing I've done here is written that I'm going to take the first derivative of my r function in terms of time. And notice that after I've taken the derivative, I have kept my x and my y separate. So I've taken the first derivative of the x component of our function. So I've taken 2 times 3, which is where the 6 meters per second squared comes from, subtracted 1 from the 2 to get the t, and I left my x hat there. I've then taken the first derivative of the y component of that function. So I've taken 3 times 2.5, which gives me 7.5. I've carried my units down, and then t cubed becomes t squared. I then plugged in the 0.75 seconds into the x component, which gives me 4.5 meters per second. So notice that the units do work, so you're taking meters per second squared times seconds, so one of the seconds cancels out and you get meters per second. And then for the y component, I plugged in the 0.75 seconds again and I get 4.22 meters per second. So notice the units do once again work themselves out. So we have meters per second cubed times seconds squared, because we have to square the time for this term. So this 2 cancels out, this becomes a 1, and we're left with meters per second. Alright, so we have an x component of 4.5 meters per second, and we have a y component of 4.2 meters per second. We now can use Pythagorean's theorem. So we're going to take the square root of the 4.5 meters per second squared plus the 4.22 meters per second squared. And that's how I got the 6.17 meters per second. And then since both the x and y component of the velocity are positive, it tells me I'm in the first quadrant. So we have Vx and Vy. So V is going to be up in the first quadrant, and my angle theta is going to be above the positive x-axis or north of the east direction. So I'm going to use inverse tangent of Vy over Vx. And when I do that, I get 4.3 or 43.2 degrees. So it's very important whenever you do these problems, you take note of where there's x, y, and z hats, because that means that you need to keep separate the x term and the y term, not add them together. So remember, you can't add x's to y's, you can only add x's to x's and y's to y's.